Okay, so what we're going to talk about today is basically taking some function graphs and then some function equations, and we're going to try to work our way through a lot of different parts of those things. So we're going to start with a graph and build some things off of that, and then we'll go to an equation and build some of the same exact things out of that. So the idea is that you tie those things together. The graphs and the equations, they go together. They are one and the same out of that. So when you look at this graph, the blue line represents all of the ordered pairs. We know that when you have a line, this is probably a cosine graph. I can't remember which one it is. It's either a sine or a cosine, depending on what's shifting. I used 2 semesters ago to draw that picture, and it worked out pretty good, so I just kept the same one. But anyway, the idea is that blue line represents all the ordered pairs that exist for this particular function that I've graphed here. And what we're going to do is answer all those questions that are down there and then a couple more about this one. So the first thing it asks for number one there is, what is f of 0? So what does that mean in terms of the graph? No. Wherever x is 0, what is y? Remember, f of x is the notation. So function notation says f of 0. Then where is x 0? At 4 on the y-axis. So the answer to that would be 4. Okay, so it's basically an ordered pair. That's all that is. That function notation is just a fancy way of writing an ordered pair. So number 2, where is f of 3 pi over 2? 0. The y value that goes with that x value is 0. Okay, so whatever's in the function notation, that's x, and you're trying to find y out of that. All right. Let's state number 3 is the domain of that function. So we have a graph. What does domain relate to? The x value. So x travels which direction? Left to right. So how far does this graph go left to right? What's the lowest x value? What's the highest x value? 4 pi. Okay. So our domain is from 0 to 4 pi. And it's easiest to write in interval notation, so that's where I'm going to start with. 0 to 4 pi. Why did I put brackets on those and not parentheses? Yeah, those dots are filled in there, so they're included. If those dots were empty circles, I didn't do that. Let's do that. If that was an empty circle right there, that would be a parenthesis that you would use. So keep in mind, as you're looking at graphs, empty circles, those are skipped numbers. So that's parentheses in interval notation. But originally it was filled in, so I'm going to fill it back in. All right, now, set notation for that. A little bit more difficult here because you've got a starting point and end point. But the x values, all x's, as long as x is between what two numbers? 0 and 4 pi. So we put less than or equal to. Remember those sandwich inequalities from Algebra 1? A little bit from Algebra 2. We did those. So that indicates x is between those two. The range. So we're looking at the range of the graph. When you're reading range with functions or polynomials, or here we're dealing with a oscillating function here. How do you read range on a graph? From bottom to top. Bottom to top. It's up and down. The y values are what decides all that stuff. And so what is the lowest y value? What is the highest y value? Positive 4. Does it matter how many times that occurs? No, it's just what's the lowest, what's the highest, okay? So for this one, the range, again, we can write it in interval notation from -4 to +4. And yes, it does matter what order it's in, because your interval notation should always be smallest number first and go, bottom to top. Range is bottom to top, domain is left to right. Okay. The set notation for that be y such that -4 is less than or equal to y is less than or equal to 4.
Wait, so why is it, so why does it start with -4 instead of regular 4? The regular 4 is earlier.
But it's earlier left to right. When you read range, you want to read bottom to top.
Oh, okay.
So math's a little different than English. We usually read from top of the page to the bottom. With the range, we want to read from bottom to top because you want to list your lowest y value first in your range. That's the reason. Good question. All right, number 5. This is getting a little tougher here. How many times would y equals -2 intercept the graph, or intercept the graph? How do you know? What does y equals -2 look like? Yeah, it goes straight across. It's a horizontal line right there. Right? And it crosses it in 4 places. It didn't ask what 4 places. It just said how many times. Okay? If we had to find those things, we'd have to have a little bit more information about the equation that this blue line came from. We'd have to have a little bit more information about that. We don't have that information. So this would be 4 times. All right, here we get into a little bit more thinking. Number 6, where is f of x greater than 0? So what is that asking? Where are the x or y values? I heard both. What does f of x mean? That means y. Where is y greater than 0? So when we look at that graph, where are the y values greater than 0? When they're above what? Above the x-axis. So there are several places that's happening. Right there, and all of those places. So we've got to list all of those places. So we're going to list them as intervals. Okay? Because all of those points on this first piece that I've highlighted, all of those points, the y values are greater than 0, correct? All right. So what's the first, when we ask for where the y value is greater than 0, we're asking for a x representation of that. So when we talk about intervals where y is greater than 0, we're actually going to look at the y values, but we're going to report x values. So our answers are going to be the intervals over x. So what's the interval for that first little leg? 0 to where? No. Pi over 2. You got to pay attention to the ordered pairs there. So the first interval is from 0 to pi over 2. Now, if it's an interval, that means it's got to have brackets or parentheses. So which one does it have on the 0? Why a bracket on the 0? Yeah, because the ordered pair is 0, 5, or 0, 4, excuse me, right? So the 4 is greater than 0, so that y value is included. Pi over 2, what's the y value? 0. So is it included? No, because the inequality says greater than 0. So if the y value is 0, then it's not included. So it's going right up to the edge of pi over 2. Okay, so that's the first interval. What would be this second interval, that hump in the middle there? Remember, the intervals are the x values. Parentheses, 3 pi over 2. And parenthesis or bracket on the 5 pi over 2. Parentheses. Okay. And then that last little piece, what's the interval for it? 7 pi over 2 to 4 pi, and a bracket on the 4 pi. Those are the intervals in which f of x is greater than 0. Okay. We're writing those in interval notation only, not set notation. Okay. We got it. This is where we start transitioning over. No, because it's not, we're just getting the pieces that do that. We're not looking at a domain. Domain puts it all together. When we're looking for just parts that do a certain thing, we're not gonna have the unions with that. Just commas or semicolons to separate's fine. All right, number 7. Where is f of x equal to 4 or negative 4? Excuse me. So this one is kind of like number 1 and 2, except for it's the other direction. They're giving us what value? X or Y? Y. Negative 4 is a Y value because it says f of x equals negative 4. So negative 4 is the Y value. So they're wanting what? The X values that have that same Y value. So what X values have negative 4 as a Y? Pi and 3 pi. I'm emphasizing the X equals there. So we pay close attention to that. All right. And then the next thing they're asking for are intercepts. And so I went ahead and reminded you what kind of intercepts we can have. Now, Y-intercepts, we can have X-intercepts out of that. So this one's a little easier on the Y-intercept, so let's do that one first. What's the Y-intercept? 0, 4. Ordered pair. 0, 4. Now, here's where it gets sometimes confusing in this section, is because when are you talking about an ordered pair? When are you talking about an interval? We're talking about intercepts. Those are places, one single spot. So those are ordered pairs. So be careful and don't confuse ordered pairs and intervals, even though they look very much the same. You've got to be careful about which one you're talking about. X-intercepts. Where are the X-intercepts for this graph? Pi over 2, 0. 3 pi over 2, 0. 5 pi over 2, 0. And the last one is at 7 pi over 2, 0. So we're just looking at where is this thing crossing the x-axis for getting our x-intercepts. You can probably add the next 2 questions right underneath that on the same page, so you don't have to flip back and forth. And I just gave myself a little more space. Number 9 is, where are the intervals of increase? What the heck does that mean? What does it mean to increase? Going up in which direction? To the right. Think about when you look at that graph, think about which pieces of that have kind of a positive slope out of that. And positive slope goes up and to the right, correct? So that's an increasing piece. Okay? So where does it where is it increasing at? Okay, so we're going to get the interval for that, and intervals are going to be our X interval for that. So it's increasing from pi to 2 pi. That's one increasing interval. So from pi to 2 pi. And we're going to put parentheses on those, because what's it doing at pi and what's it doing at 2 pi? It's changing directions, right? That's the bottom of the trough and the top of the trough there on the top of the hill out of that. So there's one increasing interval. What's another increasing interval for that graph? 3 pi to 4 pi. In Algebra 2, what did we call this point down here at the bottom, the pi negative 4? What was that called? No. Try that. If it doesn't, it's hard to remember because different subjects are different ways. All right. Okay. So it's not a vertex. If it were a parabola, yes, it would be a vertex. What kind of minimum? Why is it a minimum? It's at the bottom, right? It's a local minimum. Okay, right? Because it's in one spot, the lowest spot is -4 is the y-axis. So that's a local minimum. And then up here at 2 pi 4, that's a maximum. You remember that from Algebra 2 stuff. Those things, those minimums and maximums are where we had changes in direction. And that's where we have differences in the intervals out of that. So when we get local maxes and local mins, those are where the changes in direction happen out of that. So when you're looking at graphs, local maxes and mins are going to help you find those. Let's get the intervals of decrease. You guys have probably already done that, or already know what that means. What's decreasing mean? Going down and to the right. So like a negative slope. Okay. Where's the first interval of decrease for that problem? 0,4 to pi -4. So 0 to pi. And again, I'm going to put parentheses there. I really don't know what's happening with this graph to the left of 0 because I don't have anything else going on there. So I'll put parentheses there because I don't know what's happening. And then what's the other decreasing interval? Good job. So that's not a hard thing. Looking at a graph and finding those pieces. Not too bad. Let's do something similar with an equation. Answer some of the same questions. So you can do this on the back of that sheet or on another piece of notebook paper. I don't care. Whatever you want to do. It's your notes. All right. So here we have a rational equation. Not that it really matters what kind it is. But x plus 1 over x plus 2. And we want to state the domain of that equation first. How do I find the domain of that? Set what equal to 0? Bottom of it. So x plus 2 equals 0. So x cannot be -2, right? Interval or set notation for that would be x does not equal -2. What is the interval notation for that? Remember, we want to kind of get better at that. How could I find the range if they asked for that? How did I find the range on the first example? I looked at the graph, didn't I? Yeah, you got a graphing calculator, use the thing. Graph it. So I'm going to go to y equals. I'm going to put parentheses x plus 1 divided by parentheses x plus 2. Rational functions, they have a little different look. But what does it look like the range might be? Negative, and read the bottom to the top, so negative infinity, because that part on the right there is going down to negative infinity, right? It looks like there's a little bit of a gap there in the middle, right? Looks like 1 maybe out there. That looks like where there's a little bit of a gap for the y value of a 1, and then it goes up after that to positive infinity. So the idea here is if they ask for the range, you got a graphing calculator. Graph the thing and try to build it off of that. Okay. Most of the time with the functions and if they give you an equation, they're going to give you either ones that have a pretty easy to read range, or they're only going to ask you for the domain anyway. That's where we focus most of our time is domain. But don't forget, you got a graphing calculator and it'll graph things so that you can look and see the range out of that. And the graph is really one of the best ways to find the range. All right. Number 2 is a little bit more difficult problem. A little more specific on this because we have an equation to go by. Is 1/1/2 on the graph of f of x? And we could do that with the calculator. I'm going to show you how to do that as well, but I want to do it algebraically as well. So with just working it out. How could we tell mathematically if 1/1/2 was on in that function? It was an ordered pair that works for that function. Plug what in? If I plug in the x and get the y that goes with 1, isn't that the only y value that could go with 1, right? Because if it's a function, what doesn't ever repeat? The x values, right? So if I plug in, if I find f of 1 in this problem, end up with 2/3. Does 2/3 equal 1/2? No. So the answer to that's no. Now, graphing calculator wise, if you had to check a bunch of these, we've already graphed that function once already. Now I'm just going to check that. How do I check an x value using my graphing calculator? There's a couple different ways. What's the easiest way that maybe you remember from Algebra 2? I could do the chart, the graph. I could hit second graph and get the table and type in a 1. And I get 2/3, that's 0.66 repeating. Out of that, we see that that's not 1/2. If I'm at the graph, I can also hit trace and type a 1 and hit enter. And you can see that ordered pair at the bottom. And it shows me, hey, that 1 is not at 0.5 like we think it should be. So that tells me that it's not on the graph either. Okay. I wouldn't try to zoom in and find it, because if they're asking you if 0.7 is on there and it's really 0.65, I don't know of any of us that can eyeball that difference in those two, especially on such a small screen like that. So either using algebraic methods like this or the trace function or the table function in your calculator are the best ways of doing that. Number 3, where is f of x equal to 2? What does that mean? Where's the y value equal to 2? All right, so I can find that by taking the equation and setting it equal to 2. Because that's the y value. F of x is y, right? So if the y value is supposed to be 2, then that equation should be equal to 2. And I can find the x value that goes with it. How do I solve this problem? Maybe this helps. Cross multiply. Yeah, when you put it as a fraction equal to a fraction, that makes it a little easier looking. So x plus 1 equals 2x plus 4. Subtract 4. Subtract x. Negative 3 is equal to x. So x is equal to negative 3. That is where the y value is 2. The graphing calculator, you can't type a y value and get the x value back. It doesn't work that way. It ain't that smart. It can do that kind of stuff. So this is really the best way. Better than guessing x values until you find 2. That probably would be a good idea. All right. Now, number 4, last thing of the day, let's talk about intercepts. How to find intercepts given an equation. I wrote the X intercepts first this time and then the Y intercept. Doesn't matter. You're going to find them all. So How do we find, let's do Y-intercept first, because that was easiest on the graph, so it's got to be easiest on this too, right? How do you find a Y-intercept given an equation? Plug a 0 in for x, so we're finding f of 0. So that'd be 0 plus 1 over 0 plus 2, which is 1/2. So our Y-intercept is the ordered pair 0, 1/2. If I look at my graph, does that look about where it's at? Yeah, if I hit trace 0, my Y value it shows me is 0.5 at the bottom. That's 1/2. So that makes sense. That's the right thing. We can always kind of duplicate a lot of things we're doing by hand with the graphs and the calculator. We can duplicate a lot of it. All right. The last thing here is the X intercepts. How do you find X intercepts? Set the Y equal to 0. So that means we're going to take the function and set it equal to 0. So if we set an equation equal to 0, we will find the X intercepts. So how do we solve that? Cross multiply or multiply by x plus 2. So that's going to be x plus 1 equals 0. -1. And that's the only one we have. If I look at my graph, where's it crossing the x-axis? Boom, right there at -1. Hit trace, -1. The y value is 0. Those things tie together. Nothing. Okay. All right. So, way it worked out this week. Monday's going to be a work day, so you'll come in on Monday without a quiz, except for Maggie. She's going to take her quiz from today on Monday. But these will be the problems that you'll be looking at in this section. This section's a little bit different in that you got to look at some graphs, you got to look at some equations. It kind of mixes things up. It asks questions in a much different way than what you've been asked before. So you've got to be, you definitely need to make sure you're working on this practice to make sure you're doing the right things, okay? It would likely be a good idea, probably,